Hi, previously we tried one example regarding the curtailments of reinforcement bar in simply supported slab using the simplified rules for the curtailment. Today we're going to try another example under different circumstances, also dealing with the curtailments of reinforcement bar in simply supported slab. The purpose here is to demonstrate to you how do we do the curtailments under different circumstances. By taking the simplified rules as the guideline, sometimes the final outcome in terms of the layout of reinforcement is not fully covered by the simplified rules. There may be other considerations which overrules the guidelines given by the simplified rules. Without further ado, let us get started. This is the simplified rules given, and these are the details of the simply supported slab. Assuming the slab is simply supported in all four edges, the slab has a width of 3 meters and a length of 3.5 meters. It is a rectangular slab, and the thickness now is 175 mm. Due to relatively short effective span and the relatively thick thickness, from your initial calculations, you realize that you do not need much of the reinforcement. Having some basic knowledge about the maximum bar spacing, these are the proposed reinforcement bar for the slab. For the main reinforcement, you use #10 400. As for the secondary rebar, you use #10 450. Now you are asked to do the curtailments for the reinforcement bar and come up with the final detailing. Now, before we start, certain things that you need to know. First, this simplified rules is only applicable when the load is substantially uniformly distributed load. Second, there are other considerations that could govern the final layout of the reinforcement. This include the maximum bar spacing that is used to control the cracking. Secondary reinforcement bar should not be less than 20% of the main reinforcement bar. The provided reinforcement bar should not be less than the minimum bar area. Consider the minimum bar curtailment as given in the simplified rules, and also the dimensions are to be rounded out to the nearest 25 mm. This is for easy conversions between the SI unit and imperial unit. Having this set, let us look into the calculations. Your initial plan of #10 400 as the main reinforcement and #10 450 for the secondary reinforcement is not applicable as it does not fulfill the requirement of minimum bar area. How do you know that? You may refer to this formula. Let's say now your concrete grade is 30. You need to first find the FCTM, get the effective depth, substitute the specified yield strength of the reinforcement for you to obtain the AS minimum. Your effective depth is calculated on the basis of the thickness of the slab minus the nominal cover minus half of the bar size, which in this case is 10 mm diameter, divided by 2. As for the effective depth in the secondary reinforcement bar, you will take the thickness 175 minus the nominal cover, which in this case is 30 mm, minus the size of the main reinforcement, and then minus half of the bar size of the secondary rebar, as the effective depth is calculated on basis of the top of the beam to the centroid of the reinforcement. And then you need to get the FCTM. There are two ways for you to obtain FCTM. It is either referring to the table given in Eurocode 2, table 3.1 in Eurocode 2, This table provides you the properties of the concrete in accordance to the strength class. Given the FCK, you can go to FCTM and your FCTM equals to 2.9 for FCK grade 30. Alternately, you may use the formulas given in table 3.1. There are two sets of formulas here. This formula is for concrete grade 50 and below. And this formula applies to concrete strength greater than 50. In this case, your FCK is 30. That means your FCTM will refer to this formula. Substitute 30 into the formula. You get 2.9. Based on the effective depth that you have calculated. And the B here is 1000 mm, representing one unit width in the design of this slab. Your FYK now is 500. Substitute into the formula, you get the AS minimum. This AS minimum is to be compared with the total areas provided. The main reinforcement is insufficient, which is less than the AS minimum. Also, the secondary reinforcement is insufficient as compared to the AS minimum as well. Therefore, you will need to increase the areas of the reinforcement. This can be done either by reducing the spacing between the reinforcement or increasing the size of the reinforcement based on the areas calculated. Compare again with the AS minimum. You may only proceed when the AS minimum is fulfilled. Let's say now we have decided to increase the amount of reinforcement bar slightly by simply reducing the spacing. Now, instead of providing H10 400 for the main bar, the spacing is revised to 350. As for the secondary reinforcement, the spacing is revised to 400. Now we have confirmed that the amount of reinforcement bar provided is sufficient. We will proceed with our checking for the maximum spacing. There are two methods to check for the maximum spacing, which is governed by the thickness of the slab. In this case, your thickness is 175, which is less than 200 mm. A more simplified rule is applied. The main bar will be governed by these two. 3 times the thickness of the slab and shall not be more than 400. 3 times 175 equals to 525 mm. This value is larger than 400. Therefore, we will adopt 400 mm. As for the secondary reinforcement, 3.5 times 175 gives you 612.5, which is also greater than 450. So the maximum spacing it will be 450. Compare your spacing against the maximum spacing. The spacing provided is acceptable. With that, we have more or less confirmed the reinforcement bar to be provided in this slab. This represents 100% of the reinforcement bar in the main and the secondary directions. Now we look into how do we do the curtailment. When we want to do the curtailment, by reducing the 100% rebar into 50% rebar, you can simply double the spacing, like what we did in our previous example. That means for every 2 bar, you curtail one of the bar alternately at this location. However, in this case, your slab is already lightly reinforced, barely past the minimum AS, as well as the maximum spacing. It is unrealistic for you to reduce the reinforcement bar further. If you reduce the amount of reinforcement bar by 50%, that means the provided bar area at these regions you will be less than the AS minimum, which does not fulfill this requirement. Now, if you do the curtailments of the bar alternately, your spacing it will be double. This does not fulfill the requirement for the maximum spacing as well. Out of this constraint, this simplified curtailment rule is not applicable. And at the end of the day, there will be no curtailment. You're going to use the same amount of reinforcement bar throughout the entire slab. For the main bar, #10 350. As for the secondary bar, #10 400, without any curtailment. Since you are not doing any curtailment, it is not necessary for you to calculate this, leaving you the final design. The entire slab has the same amount of the main reinforcement bar and the secondary reinforcement bar without any curtailment.